Good afternoon, ladies and gentlemen. It's my pleasure to introduce Professor Tomáš Kozubek from the Technical University of Ostrava, who is the speaker today. In fact, I had him in mind for a long time, and I wanted to invite him, but somehow it happened only now. And so Tomáš Kozubek studied at the Technical University of Ostrava, then he did PhD. I think his advisor was Jaroslav Hoslinka, right? So. And then from 2013, he is a professor of applied mathematics, and now he's also the director of the IT4Innovations National Supercomputing Center. And his specialization is development of parallel algorithms for large engineering programs. And I think from this pocket, so to speak, he will also give a talk today.
Okay, thank you for the introduction. My name is Tomáš Kozubek, and I'm Scientific Director of IT4Innovations National Supercomputing Center. The title of my presentation is from Scalable AI to Hybrid Quantum and the IT4Innovations Computing Continuum. At the beginning, I will say a few words about IT4Innovations. IT4Innovations was established in 2011. In Ostrava, and as part of PSB Technical University. It means particularly we are a university institute. But we play also the second role. We are a member of eInfra-CZ, which is a large Czech research infrastructure. And together with CESNET and CERIT-SC, we are focused on HPC, cloud data, and open science technologies and services. And those technologies we provide and operate within the Czech Republic. Okay, in this moment, we have 5 research laboratories at IT4Innovations. It's about 100, now even more than 100 full-time equivalents, and all of them, all this research staff is focused on HPC, which is high-performance computing, high-performance data analytics, artificial intelligence, and quantum computing. That's the main 4 directions. We have also strong international collaboration. We participate in many different EU initiatives. The most important is Euro HPC joint undertaking, and I have a special slide related to this initiative because thanks to this initiative, a lot of things in HPC, quantum, and AI happened. And then a lot of other initiatives again focused on artificial intelligence, quantum computing, and data analysis. Currently, we operate 2 supercomputers. I have also some pictures of our supercomputers, Aurora and Carolina. We cooperate Lumi supercomputer. It's not in Ostrava, in our data room. It's in Finland, in Kajaani. And in this moment, it's top 9 in the world. And we operate also 1 quantum computer. It was inaugurated 3 weeks ago. Maybe you saw this in media. And the name is PLQ. Cooperation with industry, we have 2 special platforms to cooperate with industry. One is National Competence Center in high performance computing, and the second one is European Digital Innovation Hub. And I will show you some examples how we collaborate with industry. And we offer also a lot of training and educational activities. All of them are open and for free to everybody, even from, it's open also internationally. And again, those activities are focused on artificial intelligence, how to use efficiently our supercomputers, quantum computer, etc. Okay. Let's go into details, but let's start first with some comparison of supercomputer and standard computer. It means what is supercomputer? It's a cluster of many servers. Here is an illustration. Okay. And those nodes, we say nodes, those servers, it's hundreds or thousands of such nodes. And those nodes are in boxes. We call those boxes racks. And you can see them here. Yeah, it's our Carolina supercomputer. It means a lot of boxes in 2 rows. And in those boxes, we have a lot of servers or nodes. And those nodes are interconnected by, they are interconnected by very high speed network. A lot of optical cables, as you can see here. And we have also a lot of data storage, big data storage. It means, for example, home, you have terabytes. In our data room, we have petabytes. It means everything, as I mentioned, 1,000 times bigger with respect to the size. And let's go to this promised initiative, HPC joint undertaking, why it's so important. It was established in 2018. In this moment, it's composed of not 35, but 37 members, and the 3 private members. ETP4HPC, it's the European Technology Platform for High Performance Computing, Big Data Value Association, and Quantum Industry Consortium. IT4Innovations, as part of BSB Technical University, we are member of all those initiatives, and the goals are very important for Europe. The first is to create a federated high-performance computing, quantum computing, and AI infrastructure in Europe. The second, to build and create European technologies and applications to be independent, of course. And also the third, to be the leader in the HPC use and skills. It means in training, educational activities. And they have a very nice financial scheme. It means they took money from 3 different programs, from Horizon Europe, Digital Europe, and Connecting Europe facility. And they doubled those money through contributions from member states. And using those money, they try to satisfy these goals, which I mentioned. It's very, very important. And you will see on this slide how it works in practice. Because here is the most powerful supercomputers are registered in top 500 list. And here is only top 10. It's current list. Yeah, it's updated every 6 months. Yeah, it means there are new and new supercomputers worldwide, except Chinese supercomputer, because China stopped registration because of some sanctions, politics. But you can see here supercomputers, US supercomputers are Capital, Frontier, Aurora. They are mainly in US research labs like Argonne National Lab, Oak Ridge National Lab, Lawrence Livermore. But the first position is Jupiter Booster, and it's a supercomputer which is in Germany, it means in Europe. And there are also other European supercomputers, Leonardo, Lumi, Alps. And 3 of those supercomputers I mentioned, these European supercomputers, are supported or co-financed by EuroHPC. It's Leonardo, Lumi, and Jupiter. It means thanks to EuroHPC, thanks to this initiative, these 3 supercomputers are in top 10. And there will be also another one, which will be put into operation next year in France, and it will be another very big European exascale supercomputer, and Jolly Rock is the name.
Can I ask you?
Yes, please.
When China was still registering in the database, is it like, let's say, if China was in, would this be rather like top 20 or?
Oh, it will be a mix of US, European, and Chinese supercomputers.
Exactly, like would it be the first top 10 would be China, or maybe 2 of them would be Chinese by rough estimate?
Approximately like US. It means, let's say, 4 US, 4 Chinese, and the rest Europe. Okay, and here is the history of our supercomputers, which we have in our data room, or we had. The first 2, Anselm and Salomon, they are decommissioned, means you can't see them anymore. But Anselm was our first supercomputer. It was relatively small, but at that time there was no building. It means it's a completely outdoor solution. You can see on the picture only some boxes. Yeah, and the whole supercomputer are in these boxes. It was completely outdoor solution. The second is Salomon, and it was number 40 in this top 500 list. I think it was that time. It was really a great success in 2015, and at that time there were also Chinese supercomputer. Yeah. It means number 40 was really good. Okay, and Salomon had 2 petaflops. To remember, peta means 10 to 15. Yeah, it means petaflops is the unit how to measure performance, and 2 petaflops means 2 times 10 to 15 operations per second. in floating point operations. Okay, and then in this moment, I mentioned we have Carolina and Barbara in our data room. Carolina is about 16 petaflops, and when it was put into operation, it was number 69 at that time. And Barbara is relatively small, and it was, let's say, a replacement of Anselm, and the Carolina is replacement of some supercomputer. It means all the time we have one big cluster and one small cluster. That's, let's say, our strategy. And I mentioned that we cooperate also and co-provide also LUMI supercomputer. It's number 3, or it was number 3 in 2021 when it was put into operation. And now it's number 9. It means still very good. One of the biggest publicly available European supercomputer. Now, the first one is in Switzerland, and this is the second. Okay, and I mentioned also that we provide also inaugurated 3 weeks ago our first quantum computer. It's the only quantum computer in the Czech Republic, and I will have a few slides about, let's say, parameters and how to access this quantum computer, how to access other supercomputers, etc. And soon, let's say, in the first quarter of 2026, we will put into operation also Barbara next generation. It means we'll keep the names Barbara, Carolina, and there will be only this NG, like next or new generation. Okay. Here is one slide about Carolina. You see that it was put into operation in 2021. It was number 69 that time in this top 500 list, but also some green 500 list exists. It means it's the best supercomputers, the best hardware with respect to energy consumption. And Carolina was number 8 at that time when it was put into operation. It was a very good result. And you see that Carolina is also a Euro HPC supercomputer, because 1/3 is paid by Euro HPC and 2/3 by Czech funding. It means 2/3 is only for the Czech Republic, for users from the Czech Republic, and 1/3 for the rest of Europe. Okay, total investment is about 15 million euro for those boxes you see with all nodes and all technologies. And in this moment, there is about 2,000 active users and with more than 700 projects they solve. And here is also some structure. For example, Carolina has some different parts. This supercomputer. Universal part, it's about more than 700 CPU nodes, CPU servers. It means there is no acceleration using graphical cards. There are only CPUs. And it's CPUs from AMD company. And altogether, it's almost 100,000 CPU cores. It means you have a lot of units to do some special work, which you can use for, let's say, large and massive parameterization of your jobs or of your work. Then you have accelerated part. It's only 72 nodes, 72 servers, but each of them has 8 graphical cards. And this part is very important for AI community of the Czech Republic, but also of Europe, because it has almost 600 graphical cards from NVIDIA, A100, particularly graphical cards. And as I mentioned, it's possible to, let's say, train different AI models using this part. And if you need much more graphical cards, then you can jump to LUMI supercomputer, and LUMI has 12,000 graphical cards. It means here 600, LUMI 12,000. There is also one special server with for, say, data processing, and it has not in RAM not in gigabytes, but in terabytes. Particularly 24 terabytes of RAM. It means really you can put there a lot of data and process them. And then there is also some cloud part for cloud services and a lot of different data storages. And all parts are interconnected with these data storages by InfiniBand network with full fat-free topology. The most important is project storage, because from project storage you can access all supercomputers and and store the project data. Here is one slide from installation of supercomputer, because this installation, it's not within 1 month, within 2 months. You see that we started in December 2020, and final acceptation was July 2021. It means more than 6 months to install everything with respect to hardware, software, and to do all these acceptation tests. Okay, and here you can compare Carolina supercomputer with Lumi, because Lumi, as I mentioned, is one of the most powerful in Europe, and it's manufactured by Hewlett-Packard Enterprise. It's the same company as for Carolina. I think this is the same, but the total budget is here more than 200 million euro. Carolina, 15 million. Here you have more than 200. And again, I mentioned it's Euro HPC. It means 50% is paid by Euro HPC, and it means everybody from Europe can access Lumi supercomputer. It was number 3 in top 500 and also in Green 500 lists. And the period of operation is from 2021 to 26. It's let's say provided by consortium. It's led by Finland, and Czech Republic has 2.5 share related to this, to all capacities. It seems that 2.5 is very small, but it's not small. It's like another Carolina. It's because of this performance, which is more than 530 petaflops. You can compare it also with, let's say, modern laptops. It's like 1.5 million of laptops. If you put all boxes into area, you cover twice the size of a tennis court, and the weight is more than 150 pounds. It means there are some basic parameters, and you have, I mentioned 12,000 GPU cards, but not from NVIDIA, but from AMD. Because sometimes people or our users have workflows which are very good for NVIDIA. And if you want to move to AMD, you must do sometimes only small changes, but sometimes it's almost impossible. It's very difficult. Okay, we have also and it has also 500,000 of AMD EPIC CPU cores. It means Carolina 100,000. Here it's almost 500,000 CPU cores. Means this is simple comparison, Carolina versus Lumi. Okay, and at IT4Innovations, we have also some visualization virtual reality labs. They are very important because everything what we simulate using supercomputers, we can also visualize. That's the idea behind. And we can visualize this in some 3D cinema or in some using some special virtual reality headsets. And I mentioned that very soon we plan to have a new contribution to our supercomputers. It's Barbara Next Gen. It's more than 140 nodes with very modern processors from Intel company, particularly Intel Granite Rapids. And each node will have enough memory, and it's for complex memory problems to solve. It's not accelerated. Accelerated will be Carolina NG, which will be available in 2026. Means all the time we need new and new supercomputers because it's maximum for 5 to 6 years, the period of operation. Okay, and now let's switch from standard supercomputers to quantum computers. I mentioned that it was inaugurated 3 weeks ago. Our quantum computer name is VLQ, and it's from IQF company. It's a Finnish company. And with respect to some technical highlights, it's a superconducting qubits, superconducting technology. It means at the bottom of this part, where is quantum chip, there is the temperature 10 millikelvins. That means minus 276 degrees of centigrade. And it's very important because with this technology, each technology has some advantages and disadvantages. Because you have also some ion traps, neural atoms, or neutral atoms, some optical technology based on photons, and 6 different key technologies, and Europe has all of them. Because of Euro HPC, it's again Euro HPC quantum computer, and there were special calls for new quantum computers to cover the map of Europe by quantum computers. It was the idea of the call, and we succeeded within the LUMI consortium. It's therefore there is this LUMI Q. It's not exactly the same partners as in the case of LUMI, but the core is the same. And we succeeded, and other, let's say 9, altogether it's 10 quantum computers will be implemented. 2 of them were inaugurated, and also 1 in Poznan in Poland. Okay, we have 24 physical qubits in star-shaped topology, as you can see here with the illustration. And it has some advantages like minimizing swap operations, optimizing quantum entanglement, reducing error rates, etc. But what is also important, the following part, here is illustration. It means if you visit our center, you will see such a quantum computer from IBM company. And it has, let's say, 3 main parts. One is cryostat. In the middle, on the left, you have a special rack with, with different equipments to measure and control this quantum computer. And on the right, you have everything which is what is related to cooling. Because we need to cool to this 10 millikelvins. Therefore, it's not possible using, for example, nitrogen, but in this case, you need helium, and particularly isotopes of helium-3 and 4 in this case, to cool this to 10 millikelvin. And with respect to parameters, there are 2 very important. One is this fidelity, and it's related to accuracy. And this accuracy is only 10 to -2. It means only 2 valid digits. In doubles, we will have on standard computers, we have 15 digits, here only 2. It means it's really noisy, this first quantum computers. But there is some roadmap that within 5 years, it will be 10 -7, then up to -10, etc. That means very soon, the accuracy will be better and better. And also there is some very important parameters, this decreasing time, because you need, it's in microseconds. It means each simulation must be executed within those microseconds. And then because you need to keep the quantum state as long as possible to measure also the information. And you can do all this, let's say, simulation and measurement within 20 microseconds. And then you can somehow restart everything and run another simulation, another. And because it's statistical process, it's not deterministic in the result. It means you need a lot of such simulations. And at the end, you obtain some statistical results. Okay, this is, let's say, a few words behind that. And here is only some illustration how it's combined with standard supercomputer. It means on the left, you have Carolina, for example, HPC machine. And here is quantum computer. And it means you can run in Python some code on standard supercomputer, Carolina, for example. And if you have there some part which can be accelerated using quantum computer, some optimization problem, for example, you can offload this part to this quantum computer, run it or execute it, and get the result back to Carolina and continue in the execution on standard supercomputer. It means it works in this hybrid way. Therefore, most quantum computers are in data rooms together with other quantum standard supercomputers, because a lot of examples of that time, they work in this hybrid way. Okay, and the second possibility, we have special web-based interface. It means through your web browser, you can access a quantum computer very simply, and you can manipulate using microwave pulses with this quantum computer. But it's nothing technical. Okay, we have 5 labs at IT4Innovations, and one lab is quantum computing lab, and they prepared such publication. It's called Atlas of Quantum Computing Applications, and in this let's say publication, you can find a lot of examples. There is some, let's say, some basic or fundamental things related to quantum computing, different technologies, advantages, disadvantages, but also examples from finance, pharmacy, energy, automotive, telecommunications, chemical industry, healthcare, etc. It means you can find real examples which were simulated or executed on quantum computers or quantum simulators. Okay, it means I recommend, and you can find it on our webpage, IT4Innovations, this publication in Czech and English. Okay, and maybe you heard some words about AI factories. It's another goal of this Euro HPC or of Europe, European Union, to cover the map of Europe by AI factories. What is AI factory? It's somehow AI optimized supercomputer. It's one thing, it means hardware. And the second, it's some service center with a lot of with rich portfolio of services which will be provided to all users of this AI optimized supercomputer. And there were again special call of Euro HPC JU of this initiative, which were focused on those AI factories, and there were different cutoffs. In the first cutoff, 7 AI factories were accepted. In the second, 6, and there was also the third cutoff, but it's another slide. Let's Czech Republic is in the Lumi AI factory. It is in the first cutoff. There is a Lumi AI factory. You see this, and here is, let's say, some description of this Lumi AI. It means except of AI optimized supercomputer, it means hardware and service center. There is also money for experimental quantum computing platform Lumi IQ. It means there will be really a lot of experimental devices to train or to combine AI and quantum together. And it's again based on Lumi consortium. It's led by Finland, and also other countries are there. And what is important, Czech Republic is there. It means we are in this Lumi AI factory, and there is a significant investment in talent and competence development. But what is important, there was also the third cutoff. And within the third cutoff, we submitted a project, Czech AI Factory, our name is CHAI. And within CHAI, it was consortium of which is led by VSB Technical University of Ostrava, and there is also Czech Technical University, Charles University, Institute of Organic Chemistry and Biochemistry, Brno University of Technology, and International Neurodegenerative Disorders Research Center. Okay. And total budget was 40 million euro, 20 million for hardware, it means for this AI optimized supercomputer, and 20 million for this AI service center. And you see that it's again, I mentioned many times, a Euro HPC project. It means 50% is for the whole of Europe and 50% for the Czech Republic, for users from the Czech Republic. Okay, and there is also the name of this computer, which will be which will be available next year, and it's Carolina. We have Carolina in this moment in our data room, and this will be Carolina. And it's okay planned that it will have more than 300 state-of-the-art AI chips, and altogether the performance will be about 850 petaflops up in AI. So not in doubles, but in fold per second. Okay. And yeah, also this service center will be distributed. It means there will be AI hub and student campus in Brno, Prague, and Ostrava. And the goal is to support SME startups and institutions from the public and research sectors. Okay, it means this was a success from last week. And here I say information about current users. You can see that users of our supercomputers. You can see that there are at the first position Institute of Czech Academy of Science. Then it's our university, ESB Technical University, but it's because we somehow we created very big labs with a lot of scientists who use supercomputers. Then it's Brno University of Technology, Masaryk University. It means you can see there all large, big universities in the Czech Republic and big research centers. And what they compute, it's material science is almost two-thirds. It's 60% almost. And then it's astronomy, computer science, biosciences, earth sciences, applied mathematics, engineering. And how to access our supercomputers. It's very important. We have a special open access regular call or competition, which is open every 4 months. And within this competition, or within this mechanism, you can get computational resources or capacities. Okay, another approach is this Euro HPC JU access, and I have a special slide related to that. Yeah, but once more, if you want something small only to try, then you don't need to wait to opening this regular call. There is some fast track. It's called fast track, which is continuous call. It means you can submit project and within 1 week you have resources. Some smaller resources, but you have. This is also very important. And here you can see the list of Euro HPC supercomputers, which are now available for your research. And again, I mentioned this Euro HPC. There is special Euro HPC JU access, and you can access not only Carolina, not only Lumi, but all those supercomputers you can see here. And there are different mechanisms, regular, extreme scale, benchmark, and development access. Yeah, between different accesses, and you can choose what is the best for your research, for your needs. Okay, and here are some, let's say, examples what our users compute on our supercomputers. Yeah, you see some advanced speaker recognition using AI, some AI and the search for new drugs to treat pain and prostate cancer, laser acceleration modeling, simulation and planning of ultrasound surgical procedures, and of course, a lot of things related to weather forecast, weather prediction. And here I would like to show you also how to access supercomputers very easily using special middleware. It can be, for example, open on demand. It's say middleware which can be run in your web browser. And through this open on demand, you can upload the data, or you can first access supercomputers, then you can upload some data, and then you can run some application. Yeah, if you have, for example, MATLAB, ANSYS, Blender, etc., different applications, you can run them through this say middleware environment, and you will see your very nice graphical user interface of your code and favorite code, and remotely you will execute everything on supercomputer. It means it's very easy, and I'm mentioning this because we are developing a very similar thing, which is called Lexis platform. But this Lexis platform is somehow focused much more on complex workflows. It means a lot of jobs, and these jobs have some relations among them. And also it can be executed in distributed way. It means geographically distributed. It means for some execution, you can use more supercomputers, one in Ostrava, one in Finland, one in Germany. And you can use also distributed data storages to store data or to read data, etc. And it's why it's so important, this thing, because there was a special call of EuroHPC again to federate all quantum computers, standard supercomputers, and also those AI factories. And we succeeded also again within the consortium led by Finland with our Lexis platform. And we will implement this EuroHPC Federation platform within this consortium, where all, as I mentioned, all supercomputers of different scale. You see here red bar, red points are related to Jupiter. That's number 4 in this moment. And I mentioned Gilbert is the name of the project. Yeah, but supercomputer is Jolly Rococ. It means in France, in Paris. And it's those 2 supercomputers are exascale. Supercomputers, it means 10 to 18 operations per second. Not beta 10 to 15, it's 10 to 18. And then you have also pre-exascale supercomputers, Lumi, Leonardo, and Mare Nostrum. All of them are, or Leonardo and Lumi are in this top 10 supercomputers, and Mare Nostrum is in top 15. It means very good. And then there are also petascale, mid-range, and also quantum computers. It means if you see, for example, Czech Republic, you can find the Carolina supercomputer and also point related to quantum computer DLQ. And this is, let's say, current situation, how the map of Europe is covered by EuroHPC infrastructure. And those infrastructure will be now federated by the consortium, which you can see here. Okay, now a few examples also what we do at IT4Innovations on supercomputers. Typical example is a collaboration with Siemens, and it's creating digital twin of our electric motor. And it can be digital twin of arbitrary product, of arbitrary manufacturing process. And it means create digital twin. It means it's to create a computer model which covers all physical and chemical properties. It means the resulting model is really very, very difficult to execute, even on supercomputers. It will be difficult, but it will be possible. But you need from digital twin, it must be the reaction must be in real time. The response must be in real time. And of course, even with supercomputer, it's impossible. And how to do this? You can run a lot of simulations. You can generate a lot of data. And then you can take some good neural network. You can train this neural network and create some surrogate model, which will replace this complex part. And this really final AI model will somehow mimic the behavior of the electric motor. This is behind how to create these digital twins in practice. Okay, there is also collaboration, for example, with Borket company. It was based on different crash tests related to the situation you see. It means some seat it was virtual prototyping of the seat for trains. And again, if you want to go to special markets like Canadian market, UK market, you need to go through the certification in lab. And to get the certificate, it's again a very complex process. And if you want to accelerate it, you can create something like digital twin of this situation, this crash test, and do all crash tests only virtually on supercomputers. Not to go to the lab, because in this lab it's very, very expensive. You have to do real crash test. Okay, and we also create a lot of different platforms. I have a special slide related to that. I will mention that we have, for example, collaboration with European Space Agency, and this, let's say, collaboration was focused on creating special platform for analysis of cities in time, because European Space Agency has a lot of data from satellites in time, and you can take those data, you can process them, and you can, let's say, analyze not only cities, but also, for example, forests. We have very nice project Clara. It's a European Center of Excellence for artificial intelligence and quantum computing and system brain research. It's a consortium again of partners. You can see the logos on the top. And what is very important that it's focused on neurodegenerative diseases. And part of this project is also Clara testbed. And this Clara testbed, it will be another AI optimized, it means graphical cards, supercomputer. And this supercomputer will be again in our data in Austria. Okay, another software which we implemented, I wanted to see what is possible and what is somehow related to infrastructure. It's Merrick, and it's a software for energy efficient, for energy efficiency, how to measure it and how to, let's say, optimize and improve your code with respect to energy consumption. And here's an example, very nice. It was within a Scalable project. We cooperated with Airbus company, and they use ProLB software. It's for CFD simulations. And you can see that, for example, if we use Merrick, we can somehow optimize this ProLB code, which is based on Matis Boltzmann. And if there is no penalty, it means runtime is without change. We can save 12% of energy. But if we extend the runtime a little, just 4%, we can save 20% of energy. It means it's really very important to optimize applications also with respect to energy consumption. You know that, for example, ChatGPT and all those models, they need a lot of energy. It means it's good also to optimize such applications, all applications. We also deployed the software tool on Deucalion supercomputer and also, of course, on Carolina supercomputer, because Carolina C, it has 800 kilowatt power consumption. And we save 100 kilowatt using some optimization based on this Merrick software tool. And it means in Czech crowns, it's more than 5 million Czech crowns we save. Because normally we pay about 15 million crowns per year. And we save just 5 million only because of this. Okay, and here's another smart platform, which is called Floreon. And it's developed since 2006 or 2006. And it's for decision support system for crisis management domain. And it covers hydrology, traffic, air quality, landslides, and it somehow mixes all those things together. And it uses supercomputers remotely. It means you have some inputs, for example, from Czech Hydrometeorology Institute and from other different institutes. You have measured different data. You can visualize those data, and you can run also different simulations on supercomputers remotely. And then you can again visualize, for example, floods, and then you can find some routes how to go around those floods. It means it's a very important system or platform, and it was used by fire brigades and rescue services also during, for example, floods last year. Okay, and I mentioned that we have each collaboration. Here you can see titles of logos of our projects, some of them international projects, mainly Horizon Europe and Digital Europe. Some of them are focused on research and development, some of them on infrastructure development, some of them to support industry, as I mentioned, that we have these two platforms, and some of them on education. Okay, and to support industry, we use those two platforms I mentioned. National Competence Center It means there are a lot of consulting and advisory services, some proof of concept services, and also EDI, which is European Digital Innovation Hub, Ostrava, and there are again different services which we offer. It means we have, through this project, we have money to cooperate with industry and mainly small and medium enterprises and startups. Okay. I have mentioned also that we offer a lot of training activities, about 40 per year. All of them are focused on quantum, artificial intelligence, HPC, how to use efficiently our infrastructure, etc. And you see that 50% of participants are with foreign affiliation. Means it's completely open, and there are also 16 extra courses related to open science, because as e-infra said, we also somehow integrate this open science technologies to Czech Republic. Okay, and almost the last slide. This is related to organization structure of IT4Innovations. It's about 200 people. 26% is management and administration. 13% it's people related to HPC architectures who help our users, etc. And about 2/3 are related to research staff. And I mentioned that we have also quantum computing lab. We established this lab last year, and now it has about 10 people. Okay, and in the case we have a lot of time, and you are in our building, you can see also a lot of supporting technologies. It means it's not only about data room, supercomputers, quantum computer, but there is a lot of say supporting technologies related, for example, to fire prevention, related to blackouts. In the case you don't have energy, electrical energy, how it works, and also related to cooling, and also related to heating of our building. Yeah, because we use this extra heat from processors to heat our building, and also for hot water, for example. Okay. I have here a few slides with those technologies, but I'm not sure if we have still time.
No. I think it's interesting.
It means if you have just a few minutes, I will say a few more details about those technologies. It's the last 5 slides related to supporting technologies. Particularly this one, it's very big. It's like 12 meters together, this equipment. Because the blue part is ship engine, means it's a really very big engine, diesel engine. You see that the maximum consumption is almost 600 liters per hour. And in the case of blackout, this diesel engine will start. Here is some rotates very quickly, and because it has so many kinetic energy that in the case of blackout, it can, let's say, keep alive our supercomputers and the whole building for 30 seconds. And this 30 seconds is enough to start this diesel engine from batteries. And if it's not possible because of some trouble, some failure, it's possible to start as old cars were started using some crank. It means really it's possible also in our case. And you can see we have this device, we have twice. It means there is also some backup of that. And we can have up to 2.5 megavolt ampere, it means approximately 2.5 megawatt. And I mentioned that we need for all our supercomputers 1 megawatt. Means here you can compare it. It means still we have some possibilities. Okay, another very important thing is oxyreduct. What is this? It's related to fire safety. In our data room, we have only 15% of oxygen. And it's enough that you are not able to start fire and to propagate fire. And it's like 2,800 meters above the sea, that is 15% of oxygen. And how it works, through this in this oxygen there are special membranes, and these membranes filtrates all molecules except nitrogen. It means we create atmosphere with a lot of nitrogen, 95%, for example, of nitrogen, and this atmosphere is pushed to our data room. Yeah, this is the idea behind, and it's enough to have this fire safety. Another very important equipment related to cooling is here. We have two warm circuits and three cold circuits, and you see also the range related to cold and hot circuits, and different electronics in our data room needs different circuits, kind of circuits. It means warm or cold. Okay, I mentioned that we cool by water. It's not just water. It's a mixture of water and glycol. You see 35% of water glycol mixture. Okay. And the last thing, yeah, of course, on the roof of our building, we have also a lot of, let's say, special equipments to cool. Some of them are passive, some of them are active. Active are like chillers, and passive are like radiators, that the heat is only, yeah, how to say this word, to the surrounding places. It's radiated. Okay, and here you see heat pumps, because I mentioned that we use heat also to heat our building and for hot water, because the heat from the processor has about 70 degrees, and the water in the pipes has about 38 degrees, let's say, and we need 60 to heat our building, to use it for hot water. It means therefore we need also heat pumps. We need to add some extra heat to this. Yeah, okay, and with everything you can find on the web IT4.cz, what I mentioned here. And if you want to become our user, you can go to docs IT4.cz, and you can find there everything related to our environment, which software we have there, and I mean more details how to access supercomputers and now also quantum computer. Okay, thank you.